Okay, so here we are. It is 4:30 in Toulouse, France. So welcome to everyone to this webinar on how to get started on Space IoT connectivity with Kinéis. My name is Clément Tricot. I will be leading this session today and speaking in third position for Kinéis. Just a few tips before we start that you can see on your screen. You can ask questions by clicking on the icon with the question mark. You can see on the top left corner. Then if you have a problem with the sound, you can turn the sound off on the right-hand bottom corner. Be careful that the button has a certain delay. So please wait a few seconds if you press that button before trying again. You can also refresh your browser page. You can disconnect, then reconnect to the session, or even restart your browser if you still have some issues. If you can't see the entire slide, you have a pair of icons with zoom in and zoom out signs at the bottom of the page. So you may zoom out of the page to see the entire slide. All right, I think we're all set. Okay, so today and during this webinar, on Kinéis part, it will be divided in three parts. First, our CEO, Alexandre Tisserand, will introduce Kinéis and what we do, what we offer. Then our Chief Product Officer, Rémi Ferrier, will introduce the Kinéis products that allow to integrate the Kinéis connectivity. And then I will talk to you about the step-by-step integration of this connectivity from the device to the platform. And then after the Kinéis talk, we will have an integrator that will present to us its integration of the chipset. So as you saw in the invitation, we have a Arribada initiative with us today. So that will introduce a few pretty exciting use cases with the Kinéis chipset. All right, so let's start right now. I leave the floor to our CEO, Alexandre Tisserand.
Yes, thank you, Clément, and welcome everyone. Very happy to have so many people today. It's very exciting for us to show you what we can do with Kinéis and especially with Arribada, which is a very great integrator, which has wonderful products to show you. So I hope everyone can hear me now, and I will go on a quick presentation of Kinéis, not to be long, and after that we will talk about more concrete project. So what's up with Kinéis today? So basically, what is Kinéis? Maybe some of you don't exactly know what we are doing and who we are. So just to know, we come from CLS and CNES, the French Space Agency, who have invented the Space IoT, what we can call, since the 80s with the Argo system. And so we have been created Kinéis in 2018 and close in January, so this year, a few months ago, an historic fundraising of 100 million euros to fund the development of a new constellation. We also benefit from a 40-year experience in positioning and data collection from CLS because a lot of people in Kinéis are issued from CLS, especially on the business and operational side. And so what can you do with us? Basically, Kinéis is a global connectivity operator, which means that we provide connectivity, of course. And so you can position and collect all sorts of satellite data everywhere on the globe, whatever the condition. And with us, you can also benefit from the right price of this connectivity, thanks to terrestrial and space hybridization connectivity. We can go into the details of that later. But to be in a nutshell, we have connectivity which is universal, meaning, of course, everywhere on Earth, pole to pole, desert, oceans. simple to use, simple to integrate, which is long lasting. This is a good heritage from Argos technology. And our main goal is to make it very competitive so that we can democratize the IoT, and especially on the environmental application. So what is the Kinéis system? Today, we already have 8 satellites in orbit. Well, to be more precise, what we have is 8 payloads which are hosted on partners' satellites, like the American NOAA, which is the National Oceanographic Administration, also Indian satellites from the Space Agency, or EUMETSAT, which is the European Meteorological Agency. So all these partners have historically their own satellites, their own platform, on which we have some Argos payloads hosted. And so thanks to the partnership, we already have 8 payloads flying today in space, which means that we already have an operational service. So you can, as of today, order some dev kits and test the connectivity for real. And what is the plan for Kinéis? We are developing a 25 nanosat constellation, additional nanosatellites with propulsion that will be launched in 2022, which will make us the first European nanosat constellation dedicated to IoT. When I say European, it means that the nanosats are European, but of course the constellation is worldwide and covers the entire globe. We come with Kinéis, complementing the ground telecom networks because we are present everywhere on the globe. We can also use, with this hybridization strategy, the best of each network, either telecom networks in urban areas or satellite networks outside of urban areas. In 2022, we'll have a revisit time below 15 minutes, so which make us a near real-time system, which is totally enough for most of IoT application. We have a dedicated frequency band in the UHF and a two-way communication that allows you to download and upload 30-byte messages. We also have a native positioning available, which means that you can have device without GPS or Galileo or any GNSS chip. And with this native positioning with Doppler technology, you will have a 150-meter accuracy. And if it's not enough for you, you can also always have GPS or any GNSS chip localization, which is more precise, but this is a trade-off with your energy consumption on your device. Anyway, the goal of all that is to have minimum transmission power for maximum autonomy. We have some historical beacons on birds or any animal that can last several years, up to 12 years. I think this is the record for a bird with a small 35-gram solar panel included device. So what are our applications? Of course, we have some application related to science, to agriculture, to fisheries, because this is our base application. We also have the ability to track, to have some tracking application for the outdoor sport and to make life more secure. We can also implement Kinéis on some logistics activities or more industrial IoT activities. And today, Arribada will show us how wonderful you can have Kinéis application related to science. So very briefly, Kinéis in numbers. So here you can see the shareholders of Kinéis as of now after the fundraising of January this year. So we've been created in mid 2019. We are autonomous since mid 2019. Autonomous means that we have our own people, our own financing, and we have our own structure. We have now 35 employees, and will be 10 more by the end of the year. And despite the crisis, we're still recruiting. So check out websites for opportunities. Of course, we have, like I said, operational satellites. I mean, payloads flying on operational satellites today. We have nearly 20,000 active devices already connected today, thanks to the Argos initiative. heritage. And we made 5 million euros turnover in 2019, raised 100 million in January this year, like I said before. And this year in 2020, we plan to double the turnover and to be up to 10 million this year. So what's our partners involving in the development of the constellation? Of course, the CNES, which is a very good, strong, and precious partner, a French space agency. Also a big player in the space game, which is Thales Alenia Space, and Emeria, which is a small SME in France, specialized in small satellites, which is doing our satellite platform. And also Sealinks, another French SME, which is focusing on the payload with Thales Alenia Space. And on the object side, on the terminal beacon side development, we can first rely on a strong base of historic manufacturers, the Argos manufacturers, and we are today opening the world of these objects with new products. We have new chipset, new modules. Remy, our chief product officer, will speak of it just after me. And these new products are totally ready for integration. And Arribada, that we'll talk later, is a good illustration of that. So this means that we have a growing ecosystem and integrators and service providers. And I hope some of you today will join us for this wonderful adventure. And I'm not longer than that, and I leave the floor now to Rémi Fayet, which is our Chief Product Officer. Thank you, everyone.
So hello, everyone. My name is Rémi Fayet. I'm the Chief Product Officer. Very happy to be here with you and see you also numerous with us for this second session of our webinar. So I'll be diving into our product line. But first of all, I want to underline what Alexandre said earlier is our goal at Kinéis is to democratize satellite connectivity. So that's something we think about every day when we develop our product. We want to make it easy to use, cheap to integrate, and to speed up the process of integration as much as possible. So we're working, we're building tools in this direction. Someone has problem hearing. If you have question, if you cannot hear, let us know. Apparently it's working. Okay. So we're trying to solve some issues with this satellite connectivity. We can bring a new connectivity to remote areas or maritime zones where a terrestrial network is not available and will never be available. It obviously offers a global coverage without having to deal with roaming issues. And finally, in some situations, and it can be a good complement to terrestrial connectivity. And for all of those, we're working to build the chip devices. Okay, let me see. Some of you have issues. Not all of you. Can see the slide, not here. Anyways, let me try something. Okay, I tried turning it on and off. Can you hear me now? Some of you have problems. If you can hear me, can you put a thumbs up or something? No sound, no sound. I'm trying turning on and off. Okay, sorry for this little interruption. And we're back. Is it working better? Let's try to go on. I hope. Okay, I hear you. I hear you. I hope most of you can hear me. If you cannot, try getting out of the session and reconnecting. Sometimes it helps. So yeah, in all our product development, we try to go for small miniaturized device, low power, and cheap device. Obviously, I know a lot of you can have questions about prices. So we're trying to bridge the gap basically between old space connectivity and terrestrial connectivity. Space connectivity module can go down to 100 euro these days. We're trying to go under 30 euros, so really bringing the cost down, and also bringing the cost down of the connection and the data plan themselves. As far as power consumption is concerned, satellite can used to be quite high power consuming, and we're trying to lower this consumption from 1 watt to 100 milliwatt in average. So our product line, two basic components are chipsets and modules. Chipset is basically an RF front end that will need amplification and master control. Our module is more sophisticated. It has more development, more intelligence. It can predict the passage of the satellites, the satellite paths, and then it can do some message formatting and takes care of all the protocol stack. On top of this, we have interface board and generic terminals that are meant to be tools for integration, to prototype, and to go fast to the market. Those tools are available. We supply the libraries, the code libraries for this, and we also give the schematics of those applications, and to be able to start with demos pretty quick. A little more details about those products. The chipset is 7mm by 7mm. It's the chipset that's already integrated by our friends from Arribada. Arribada will give you more details about their integration of this chipset later on. And it comes with all the Argos uplink modulation with reference design for the integration, so all the schematics for power lineup and switches that you need to add to have a chipset that will work and connect to the satellite. And it comes with an evaluation board to start using it very quickly. The module is a more higher level integration, 2 cm by 3 cm, 500 milliamp power consumption during transmission. It can be interfaced through a standard AT command, and it's fully certified by Kinéis and Kinéis to communicate with our system. Comes on different boards, Arduino, STM32 or Mongo H boards that are pretty easy to use for developments. All of this, as I said, is part of our very open strategy. So you can start with your own hardware, your own equipment, and then use our waveform specification to build your own custom device. Or you can use our product to facilitate the integration. You can use all our open reference design schematics and libraries. And we also have antenna reference design coming to help and start on those product integrations. So from now on, our roadmap, since we already have satellites, is to deploy a lot of application with all our partners based on the existing constellation, and then we're starting to work with new partners to build demonstrators, proof of concept, and start development of new devices that will be optimized for and ready for the Kinéis constellation when it arrives. All of this is also why we are here today to start building an ecosystem around us with technology providers, integrators, solution providers that will build, thanks to all of these partners, we will build a strong community, we hope, and hopefully new applications and new usage of the satellite connectivity. Apparently, there's still some issues. Unfortunately, that's the end of my part. I will leave the floor to Clément Tricot. I hope you can get back the sound for some of you.
Okay, hi again, everyone. I hope you can all hear me. I waited a bit to turn on my mic, so I hope it's okay for everyone. I'm just waiting for some feedback on the sound. Okay, so apparently at least a few people can hear me. I hope it's the case for everyone. Okay, so now I take the presentation to talk to you about the connectivity integration. So just a quick presentation on my field application engineering position. So I am basically in charge of first the technical evaluation of possible use cases, and then of course the technical support for the integration of Kinéis products until the deployment of the solution on the field. And then I give some feedback from the integrators to the product teams for future developments. And I am also in charge of managing the ecosystem of integrators that we are in the process of building. And that is my first slide. So here you can see, if you look on the left side, you can see from the top down that we provide, of course, for the most part, the connectivity by satellite. But we also provide, as Remy just presented, chipset modules and devices. And then below that, in pink, you can see the tools for each of the two things that I just said. So for the connectivity, the tools to integrate the connectivity would be the APIs, the application programming interface. And the tools for the products, chipset, modules, and devices would be dev kits and technical support. I'm just waiting to see if the sound is okay. I know that I can see a few people can't hear me. I'll just try to turn the mic off and on. Okay, well, I hope it's working for everyone now. So as I was saying, these tools, APIs, dev kits, we provide them to our integrators, which here are symbolized by VAR, which are value-added resellers, and VAMs, value-added manufacturers, which are basically the service providers with the Kinéis connectivity and the device manufacturers. But we also provide them directly in some cases to strategic accounts or OEM, which are original equipment manufacturers, which are the ones that will integrate the connectivity directly into a product they sell. So it will be, let's say, transparent for the end user. So you can see on the right that VARs and VAMs are not the only kinds of integrators, but there are the two main ones that we have identified at this point. Okay, so now I will guide you, now that I have presented a bit the ecosystem. I will guide you through the step-by-step integration of the connectivity. So the first step would be the evaluation of the use case. That's divided in two parts, business evaluation, but also technical evaluation. The business evaluation would be identify and try to define the use case. For example, the features embedded in the device. That can be sensors, temperature sensors, pressure, light sensors. If the main necessity is to have a global coverage or in remote areas, because that is our added value with the satellite. And then if it needs an IoT-like connectivity, which means small messages at low power with the low cost. And then the technical evaluation would be diving into the device and data specifications. For the device, it would be the form factor, shape and size of the device, deployment constraints, in what environment would the device be deployed, what would be its power source and its autonomy. And then for the data, define the amount of data needed, which comes directly from the frequency of acquisition of each sensor, and the frequency of transmission of the data that is required. So then the question to ask would be, as Remy presented, we offer two kinds of basic products, module or chipset, which would be the one more suited to the development that we want to do, because both have a design very different. The module is an onboard design, whereas the chip is an ASIC design, which is application-specific integrated circuit. So what the module has its advantages. First of all, the ease of integration, because all the radio frequency components are included under the shield, and it requires only a basic communication with a microcontroller, for example, and then it takes into account the whole transmission process, and only an antenna is required at the output. Whereas with the chipset, the signals are generated, but then it needs a bit of a radio frequency rework for the what we call the radio frequency front end. So basically amplifying the signals, which has a direct consequence on certification, because the module, the Kinéis module, is already certified for transmission to the Kinéis system, whereas the integration of the chip would need to go through a new certification process for the radio frequency part, which has another consequence on time to market. Of course, the less important development needed with the module allows to have a shorter time to market. But the advantages of the chipset would be flexibility, because it allows to design to make a custom design, for example, adapted to a smaller size or adapted to a specific transmission power that we want to achieve. And then, well, I already said it, but the last advantage of the chipset is actually the size. You can see it on the picture. It's much smaller, although it needs some a few components behind. It can allow to achieve smaller sizes for the devices. So today, what does Kinéis offer? Today we offer the Space IoT program, which is a program that was created for proofs of concept to test Kinéis IoT connectivity with a privileged access. So with that said, when you enter the Space IoT program, you get a few modules or chipsets according to the choice that you made, depending on your skills and the objective of the proof of concept. You get a development kit that goes with the module or chipset. You have a time period of privileged access to the Kinéis IoT connectivity. You have a team available for the technical support. You have the access to a personalized web platform to display your data. But also, we will get into that later, but also you can set up your own APIs to recover the data transmitted by your devices. And then at the end of the project, we perform together a complete analysis of the proof of concept with recommendations for the future. So when you enter the Space IoT program, you receive this package, which has a few chipsets or modules, the evaluation board with the selected interfaces. We'll go into that later. Of course, the corresponding power supply and communication cables, an off-the-shelf antenna selected by Kinéis after a testing campaign, and modules chipsets. So you basically get everything needed to for a plug-and-play test campaign. And that is the first step. When you get the package, is to start the test with the plug-and-play evaluation board. So as you can see on the picture, the evaluation board that we provide can be plugged on the computer, and we provide a graphical user interface to start the test. This allows you very quickly to understand the Kinéis connectivity. Sorry. So you can start to communicate with the module or chipset with its own communication protocol. You can start to configure the transmission parameters for transmission towards the Kinéis satellites. You can then transmit to the satellites thanks to the antenna, with also satellite path predictions that you can import on the graphical interface. And then you can go on the web platform and access the transmitted data online. So in a matter of minutes, you have already tested the Kinéis connectivity. Then, once you have done the first test, you can actually start your development with the evaluation board and your favorite hardware platform in order to start developing something that will be customized to your needs. Indeed, as Rémi presented earlier, the evaluation board comes in different form factors for connection with the most common MCU boards on the market. So you can see here Arduino, Mango, the IoT platform from Sierra Wireless, and STM boards. You can start from the libraries and demonstration codes provided by Kinéis for these platforms, which basically include the management of module or chipset communication protocol, the transmission of messages with a custom data payload, and the example of a communication strategy. And then you can customize for your own use case. For instance, acquire some useful data from embedded sensors. There are some sensors on the market that you can plug directly into these boards. For Arduino and STM, the Mango board comes with a few embedded sensors already. And then you can also hybridize with other communication systems. also with the shields that you can find on the market with the different modules for different communications, different kinds of connectivities. The Mango also already has a way of communicating with the cellular networks. So then once you have transmitted some data, you can go online, log in the platform, and access the transmitted data. As I said, you have with the package, you have privileged access to Kinéis global connectivity during the development of the device. So you don't have to worry about the quantity of data that you are transmitting. You can do your test with this privileged access. And then you have access to the platform. You log in to access your data online. But you can also start to set up the required APIs for data redirection. So you can already redirect all the incoming data that you transmit with the device to your own platform that will be customized for your use case. So through the whole integration, we provide technical support. That includes a few tools that are available. For example, of course, the up-to-date documentation for all the products and for all the tools, documentation for the modules, chipsets, evaluation boards, but also softwares. And the API libraries written for the different hardware platforms that are presented with their documentation. But you can also benefit from custom support from Kinéis. Of course, you have after-sales support during integration. So that includes, of course, the integration of Kinéis modules and chipsets, some troubleshooting if necessary. And after that, hardware or software optimization. Also, application-specific recommendations, such as transmission strategy with a few simulations on our side. Strategy to acquire some sensor data on the device, and then follow up and testing and end-to-end validation, which includes test setup and parameters, the test results with some internal tools that we have to try and observe the performances of the communication, and maybe at the end the guiding through potential certifications. And then we have some exciting features coming soon, such as the online frequently asked question page that should be available pretty soon, and an online product catalog, so you can see all the details of the product that Rémi presented before. All right, so this is my my last slide. What are the next steps for you? If you are a device manufacturer, you will integrate Kinéis electronics into your custom connected device, which you will submit to Kinéis for registration of the product catalog that gives you some visibility. And then you can access volume pricing and direct supplies for the modules and chipsets from Kinéis. If you are a connectivity reseller, which means basically a service provider from Kinéis Connectivity, you can integrate our connectivity into your custom IoT solution, submit your solution to Kinéis for the registration as connectivity reseller, and then you access volume pricing and direct supply for the connectivity. So from today, you can already join the Kinéis ecosystem and benefit from the visibility and co-marketing operations together with Kinéis. All right, so I hope that this presentation gave you the I'm still on. Yeah. I hope that you enjoyed this presentation. I will leave the floor now to Arribada for the presentation of a few exciting use cases in environmental applications. Thank you.
Good noon, afternoon. Hello, everybody. It's a pleasure to be here today. I hope you can all hear me. I know we've had a few audio sounds issues, but delighted to talk you through what I hope is an exciting development, integrating Kinéis into products. I'm Alistair Davis. I'm from the Arribada initiative. And I want to look at unlocking access to Kinéis today with what we are calling the Horizon Arctic R2 Developers Kit. So who are Arribada? Well, Arribada is a UK technology company, and we're focused on open source conservation technologies and hardware. And we work primarily with conservation organizations globally to co-develop and integrate conservation technologies into their field programs. So we're in a space where we're not developing from scratch. We're actually looking at the value and benefit we can offer to them. And that's especially true in the IoT and satellite space. And to us, global connectivity is key. And that's why Kinéis is so vital to us in the future of the nanosatellite constellation, because we need to rapidly prototype and adapt solutions that will fit into individual environments, regardless of where they are. Because we work in the Arctic, Antarctica, in the marine environment, and the terrestrial environment as well. So we can't redevelop from scratch. We need a platform and a system that's easy to modify, quick to adapt, and that's what we wanted to develop, an actual developer's kit that will help you do the same. And why Kinéis? Well, it's pole-to-pole global coverage, which is fundamentally important to us. Low-cost chipsets. Again, we really need to drive down that cost of the chipset so we can scale up access to a number of devices and units and tags at scale. And of course, size is imperative as well. A number of our custom solutions need to track small species or small environmental objects such as plastics. So we really had to focus on a chipset and a partner that could deliver that for us. And of course, at the heart of this is an open strategy. And what you would have seen today is that Kinéis are really delivering there. They're actually letting integrators work with them in a close way. So unopening and accessing support and integration advice that helps individual producers such as myself create solutions. So this is it. This is the Arribada Horizon Developers Kit. And what you'll notice straight away is that it's in two parts. And that's an important factor for us. We didn't want to create a single unit. We wanted to give you as much flexibility as possible. And of course, it involves the Kinéis Arctic R2. We integrated that into our satellite transmitter. And we also provide a payload, a GPS GNSS solution with all the sensors and breakout connectivity you will need to develop your own bespoke products. It also comes in a box, and a few people laugh when I say that, but getting a device in a box off the shelf, which gives you access in a matter of minutes through Kinéis, is going to, I really think, make a fundamental difference in how we consume IoT technologies and how we move forward. Because we're breaking down those barriers to access, which really have prevented people from easily moving into this space. Here's what it looks like. So again, it's a standalone open source controller fitted with GPS, I2C, so you can break out into various sensors. We break out SPI and UART, all that connectivity is there. We also pack it with a good 9-axis accelerometer. And also, the reason we made this as two standalone units is because we want you to experiment and play with the satellite unit, but not have to go away and respin your own boards and pay those upfront costs to progress and move forwards. You can actually use our unit and then disconnect the transmitter, get access to our firmware and our source code, and then use that in your own proprietary devices. So you're getting halfway there to making your own solutions. You don't have to re-engineer the wheel again. So it was important for us to make sure this was really truly a developer's kit. You weren't just integrating a fixed module. All the configuration tools are written in Python. So when you're talking to the device from a Linux computer, it's nice and easy to pull data, push configuration files. The configuration files are in JSON. So we've really tried to make this a really nice environment and developer space. Performance-wise, Well, we've managed to get it down to a microamp of 20. So that's quite a good sleep current. It means you can really get long deployments when you're only transmitting, say, for a few hours a day. 5-6 years are what we've been aiming for large track plastic objects. The transmission power is modifiable. So at the minute we broadcast at about 450 milliwatts, but you can actually push that down. And the reason for that is we really want to play with the Kinéis constellation, what it's delivering. So you can save power there. So if you're in the 250 milliwatts range, it's going to save you power over time. And we've made sure that that's available through the device. And of course, it's only a Pico blade connector away from you breaking out the transmitter and connecting it to your own devices as well. And importantly, hybridization. We haven't forgotten that a number of users actually still want Kinéis and cellular or Kinéis and LoRaWAN, because you're then getting value from your deployments where when you're out of range, you're in the Kinéis world, and when you're in range, you may want to play with the technologies. So the developer's kit already supports a cellular board and a LoRa board, which will give you that flexibility to connect both Kinéis and cellular or LoRa connectivity in your devices. So what are we doing with it? Well, we've been integrating it into our own solutions. In the marine space, that means we're taking our GPS sea turtle transmitters and upgrading them and introducing Kinéis connectivity. And in the terrestrial space, I've lost my slides, unfortunately. Just going to try and get my slides back, unfortunately. I think I've lost them in the presentation. And we're integrating it into terrestrial solutions as well. So not just in the marine world, we can take the developer's kit and upgrade some of the cameras that have been out there for 5-6 years and add this connectivity to them to benefit from what Kinéis delivers. Okay, so 2 use cases today. I'm going to look at 2 integration stories. And the first is National Geographic's Sea to Source Plastics Expedition. And this was an interesting integration case because we were asked to essentially create an IoT plastic water bottle. They wanted to track plastic waste leaving the Ganges Delta in Bangladesh and track its journey in the open ocean. So we had to integrate the developer's kit into a 500 milliliter plastic water bottle. And it looked a bit like this. This is a CAD drawing of what we came up with, our solution. And we loaded our developer's kit. So we had our GPS ceramic antenna up at the front, so we get high up off the water's edge. And we had our Arctic transmitter at the back. And then we loaded it with about 6 to 9 primary cell AA batteries. And this essentially then got slotted inside a plastic water bottle. You can see here on this slide here that this is what it looked like when it was out on the water. And this was a really good integration for us because we were truly adding connectivity to a plastic water bottle without modifying its shape or its profile. So we'd hope to get the same dynamics and flow as a normal bottle would be against in the open ocean. And we're benefiting because we've released these bottles, but we know in 2022, with the release of the constellation, we're already compatible. So we will get those 15-minute revisits. And all we have to do is wait for that constellation to go up, change configurations on the devices, and then we can benefit from really high level access to from data from these tags. And of course, it's scalable. That cost reduction with the chipset means we can launch a number of bottles because these projects only work when you've got a large data set. If you really want to track where plastics move, you can't just track a single bottle. You have to really look at seasonality in different locations and how plastic it moves in the ocean. To do that, you need access to a number of devices. And the second integration story today is a really interesting one because it involves tracking coral spawn. And to do that, we had to look at how we could create a very small, lightweight device which floats on the top of the ocean, on the ocean's surface, and again do that at scale. Because as you'll see here, to track coral spawn, there are a number of variables. We have to think about how dispersal may go in any direction, how wind may affect where the coral spawn ends up. And we really want to track where the coral ends up, because we want to know where it's propagating in reef systems. And to do that, essentially we had to look at how we could bring down the cost of manufacturing a large number of tracking solutions, and also think about the sensors we could load in there. And this is what we came up with. You can see there's a render here of what we believe this device will look like, and this is for the Zoological Society of London. But we plan to deploy a large number of small, lightweight devices in unison with a coral spawning event. So the team will wait and watch for the coral spawn to happen. They will deploy 50 to 100 of these trackers. And of course, we only have to really modify the PCB footprint to create this device. We don't have to do this from scratch. We already have the transmitter. We already have the GPS, GNSS payload. And it'll probably look a little something like this, whereby our units will float on the ocean surface. We'll encapsulate that unit, so it'll be completely sealed from the elements. We can use wireless charging to charge the unit, and we can use Bluetooth connectivity to get data from the device when it's recovered. Because these are short-term deployments. These won't be left in the ocean for a long period of time. These are short-term to really track where that coral spawn moves over, say, a month's time, and then recover those devices. And we don't expect them to travel a long distance. So I'm really excited about what this project will deliver for ZSL, because it's probably going to give them access to a really rich data set. And they're looking at high-resolution GNSS fixes, say every 5 minutes for that deployment duration. We already fit the developer's kit with a BMX 160, so that's going to give them that accelerometry data they need to look at the state of the ocean and how the currents may be affected and what was happening at that time. And of course, we have I2C connectivity, so we can break out temperature, salinity sensors and expose them through the wall of the encapsulated unit. So this is going to be a really exciting deployment, I feel, for ZSL. And of course, a nice simple step here is your own product development. And we're working on a product for CLS, and this will be a generic tracker, and a tracker that really makes it more accessible for people to get access to Kinéis and get access to a device which gives you all the functionality you would want, but reduces the cost and entry points. And of course, we're still using that Bluetooth low energy connectivity to make it compatible with a smartphone application as well. So it should have that nice user experience whereby you've taken an off-the-shelf device, the developer's kit, modified it at a firmware level to do what you want, and then used your own existing smartphone application to turn it into a product. And this, I think, will be quite interesting for a number of people on the call today, because you may get a sense of just what you can do with this kit moving forwards. So that was my presentation today. Hopefully you picked that up on audio. We didn't have any issues there. But if you want to learn more about what Arribada is doing to unlock access to Kinéis, then please get in touch. And it was a delight today to present what we're up to for you all. Thank you very much.
Okay, thank you, Alasdair. We were really glad to have you speak about your very exciting use cases today. So great job. We do not have any question right now, so I hope that the sound problems didn't affect you too much. Do not hesitate to contact us. You can see on your screen the email address, sales@kineis.com. And do not hesitate to contact Alasdair from Arribada Initiative also. There are a few questions. You have a few questions to answer when you exit the session about the session today and how you liked it and if it was interesting. And we hope that you did find all the information that you were looking for. So there will be the slides available to everyone. They will be sent to you later on. So you will have access to the slides, and there's a replay available. It's already available from the last session on YouTube. And it was the same session, except for Arribada, there was another integrator testimony. But on Kinéis part, it was the same webinar. All right, so thank you all for attending, and we hope to hear from you soon. Bye.